Who wants to learn how to do text mining the easy and free way?
Great, huh?
Okay. Who raised their hand? All right, you're all in the wrong session. Text mining is neither free nor easy, otherwise we wouldn't need to have a conference. What we're going to talk about is, we're going to talk a lot about open source, but it's not costless. I'm going to try to make that point very clear. It might be less risky, but it's not costless. So before I introduce myself, I'd like to get to know who I have in the audience. So how many sort of executives or decision makers do I have? And how many people that actually do work?
Please.
Okay. So hopefully there's a message for everybody here. I hope. Now we're just going to always come back to sort of resources and costs. And how many have an active have an active text analytics project or process in-house already? And you use commercial solutions. Who uses commercially licensed solutions? Okay. And how about homegrown solutions? So some do a combination of both. Okay, great. Thank you. So my name is Janine Johnson. I work for a company called Verisk Analytics. Several years ago, the management came to us and sort of said, what technologies are we not using that maybe we can sort of monetize? And a couple of us had done text mining in a previous company. We said text mining. It's a very mature technology. You have textual assets, and your customers have textual assets. So let's monetize that. So they said, great. Go off, build us a business case, come back to us. The problem we ran into, the biggest mistake we made, was something that Tom alluded to this morning. We did not have a strategic vision. We were hoping to sort of develop a strategic vision, and we found that to be very difficult along the way. So what we did is we went out and spec'd out a commercial solution for an enterprise application that we felt would fit our needs. And we then shopped the ideas around to our business leaders and said, okay, if we had this tool, what do you think we could do with it? How can we improve our processes? What new products can we create? How would we maybe improve our existing products? Well, the idea didn't land, and you sort of get into this chicken and egg problem where it's like, well, I don't know what I can do with it until you show it to me, and it's like, well, I can't show it to you because we don't have it. That's what we're trying to do. So at the end of the day, we ended up with way up here and revenue way down here. And so, of course, the idea basically got shot down. So, well, we can't really fund this. So we didn't get dissuaded. We said, okay, we think this has value. We're gonna forge ahead. And largely, this talk is about sort of some of the techniques we've applied and tried to basically help us make our business case. So hopefully, you can take some of these techniques away to your business. We're going to briefly talk about our strategy for overcoming these barriers to entry. We'll talk about broadly the spectrum of text mining solutions and how we went about as an analytics group figuring out how on this spectrum where we would come out in terms of solving a problem. And then we'll talk about 4 case studies. And they're 4 very distinct case studies that solve 4 very different business problems and use 4 different technologies. And we'll wrap up with maybe managing expectations, or maybe better titled lessons learned. If anybody has questions along the way, please stop and ask. Hopefully I won't run too long and we'll have time at the end. So, as I said, we had all these barriers to entry. They're saying we're not funding this, but we were not dissuaded. We were going to overcome these barriers. So what did we do? Well, we felt that we had spec'd out the correct solution for our enterprise analytics. So we didn't want to sort of scale back our requirements and reduce our costs. What we really wanted to do was shore up our value. We really wanted to demonstrate the value of text mining. So we continued to shop the idea around to business leaders. We continued to look for proof of concepts that we could execute. And to Tom's point earlier this morning, we looked for small proofs of concepts. We wanted to find low-hanging fruit. We wanted to find those problems where we could get in, we could demonstrate value, and we could get out. Maybe move on to maybe a bigger project or maybe the next project. So we continued to shop it through the organization. We didn't have any budget, so we had to use our existing tools. We had to use our existing talents. and we had to use our existing hardware. So we had a 64-bit workstation that was being retired. We took that machine, put some more memory in it, identified our tools, loaded it up, and off we went. But the key idea in terms of overcoming barriers to entry is that we wanted to execute those small proof of concepts in order to get support and demonstrate business value. So there is a broad spectrum of solutions out there. I threw a bunch of them up here. If you're a vendor and your name's not up here, I know SAS is up here, right? Twice. You got 2 credits. No, if you're up here, if you're a vendor and you're not up here, I apologize. I don't have a dog in this hunt. I just wanted to throw up a bunch of examples. When we were looking at text mining solutions, we sort of classify them into sort of 3 buckets. So you have your commercial solutions, and there's a lot of them out there. And commercial solutions are very good at what they do. They're generally comprehensive suites of tools. Whatever your problem is, you can probably find a commercial solution that's going to solve your problem. They generally have a less steep learning curve, which means it's easier to get up and running. And that's really, really important, because we're going to talk about some of these over here. These get really hard to do, and you're going to have a lot of training costs and a lot of labor costs involved with getting up to speed using these technologies. So they do have advantages, but they do come with license costs. In the center, we're going to talk about sort of open source solutions. These are what I would call toolkits, or they basically have text mining components or packages or functions that perform typical tasks. They're not necessarily an end-to-end solution, but they give you a bunch of tools to use, and then you have to stitch those tools together to make your application to solve your problem. So they're sort of in the middle, right? So they do a lot of the hard work for you, but because you have to stitch these pieces together, it still requires some knowledge. You probably need some NLP knowledge. You probably need some basic programming knowledge. If you want to use Gate, which we'll talk about later, you need to know some basic Java programming. If you wanted to use R, you certainly need to know how to use the R language. So those are skills that have to be in-house if you want to use these. And again, if you have them, great. If you don't have them, not costless. All the way on the other end of the spectrum are sort of this custom-built solution, just handcrafted, and we'll talk about a couple of these. You can create these in basically any language, right? So SAS, we've done a lot of work with basic SAS. We've done some in Python. We've had some people do some work in Java. Anything that has text functions or regular expressions, you can build a custom solution. These are by far the hardest to develop. You need a fair amount of programming experience to do this stuff, and some NLP knowledge. Generally, what falls into this bucket might be like looking for specific concepts within text, maybe document clustering, something along those lines. If you wanted to, say, build a part of speech tagger, you can do it in Python. I've seen examples of it, but why would you do it? There's lots of part of speech taggers out there. It's a feasible problem, but it's not practical to build that type of technology when there's so many other things available. So this is sort of a broad spectrum of solutions. Now, we wanted to have a commercial solution and we couldn't get it. So we sort of ended up on this side of the spectrum. And when we approached projects, we had to figure out, okay, well, we still have a lot of options. How do we go about selecting our tool for any particular project? Yes, the cost. I forgot to mention that. So again, we have licensing costs over here. Over here, you're going to have training costs. You're going to have the cost of getting people up to speed. And so important, you're going to have opportunity costs. What is the cost of having someone learn how to write Python? What else could they be doing? So there are costs. None of this is costless. Maybe lower risk, but not costless over here. This is basically the thought process we went through to select a solution for solving these problems. This is pretty much common sense. And I think that you'll find that the solution that maybe we selected for a particular problem isn't necessarily the only solution. It's sort of what we selected based on what we had available and the skill sets of our people. So these are by no means the penultimate answer, but it is an answer. So the first thing we always look at is, what is the objective? What are we trying to solve? What is the business problem at hand? This really should be a no-brainer. You would think, well, this is simple, but it's not always that simple. Often there is a misunderstanding or a misconception about what text analytics can do, what it can't do, or how to even monetize it or use it. So this is a very, very important conversation to have. And at this point, you should be asking lots of questions to make sure that basically everybody is on the same page. I think the best way to characterize this is if expectations aren't met, then it's basically a bad project. And it's better to have no project than a bad project. So don't oversell the solution. Picture the business owners or your clients, whether they're internal or external, understand the possibilities and the limitations so that everybody's on the same page. Then we want to understand, if we get past that stage, we want to understand what's the input. What format is this text in? Is it coming out of a database? Is it a Word document? Is it a PDF? Oh, very important. Is it a searchable PDF or is it an image PDF that's going to need an OCR? That's a very important consideration for the client to know. So we want to know what format is the data, where is it coming from, and what volumes are we dealing with here. We also want to know what's the output. What do you want us to create? Are we creating an XML document? Are we creating some list of binary indicators? Or what are we doing? What's the output? Where are you going to store it? And what are you going to do with it once it comes out of our process? We have sort of found that these two steps are, especially with the homegrown solutions, getting data into these things and then out of them is sort of the biggest step. They need to understand how is data going to flow in, we're going to do our magic, and then it's going to go somewhere. And making sure that all of that is sort of aligned before we get too far down the road is really important. And then what are sort of your production considerations? Where is this thing going to live? Where is it going to run? Is it running on your system? And if so, in what language? Is it running on a client system? One important thing I forgot to mention about the open source things. Yes, they are open source and they're free to sort of use, but if you're going to commercialize them or productize them, really important to have legal look at the license agreement to make sure that you don't have to give away basically your IP. It's possible that if you're commercializing something, that you are going to have to sort of provide the source code and basically reveal your IP. So while they're free to use, you need to have legal review sort of the license requirements. That sort of comes into this production consideration. So if we get through all this, then we're going to sort of look at, okay, well, this is our problem set. What text mining techniques do we need? What tools are available that provide these capabilities? And do we even have the people and the skills to execute on this? And then we'll sort of select our solution. So pretty common sense stuff. That's sort of the thought process to go through how we end up selecting one of these solutions. So let's talk about sort of our first case study. In this particular case, what we were trying to do was use text to identify specific injury types. So we were working with a database that had both structured data and unstructured data. The structured data was basically ICD-9 codes for diagnosis or types of injuries, basically. But that field was relatively sparse, and we wanted to use it in a predictive model. So in order to make that field more meaningful, what we wanted to do was leverage the text to help backfill some of that sparse information. So we wanted to leverage the text to augment the structured field. We wanted to take that, and then we were going to use that in a predictive model. We were trying to predict something. Specifically, we were trying to predict fraud. So we were looking for specific injury types. The guy from SAS is smiling because it seems like maybe he's done this before. So our input was basically a Microsoft SQL Server database. It was a relatively short field, which contained information about the type of injury. Somewhat pretty high volumes, but the text fields were fairly short, so this wasn't too much of a consideration. Our output was a binary indicator showing the presence or absence of specific types of injuries. In production, this thing was going to run in a DB2 database. It would be batch processing, and it was going to be coded in Java. So whatever we came up with had to be sort of translatable to Java, either written or either we had to do our R&D in Java or we had to be translatable to Java. So we programmed this basically in SAS using the existing SAS functions, and it fit well because we wanted to do a predictive model. We were going to do that in SAS anyhow, so it was natural to do the text mining within SAS. Also, we made very heavy use of regular expressions, which is sort of down here, and I'll talk about that in a minute, for identifying our injuries. And regular expressions are available in a lot of languages, including SAS, Java, Perl, and a number of other languages. So it fit very well from going from R&D and SAS to Java because the regular expressions were pretty much directly translatable. Some of the key text mining techniques that we had to apply to this, synonym substitution was really important. I think it's come up many times, but the data is very messy. Lots of acronyms, lots of misspellings, lots of abbreviations. So we needed to make sure that we took care of all of that, standardized the data, normalized the data so that we had, instead of FFXD, we actually do that meant fracture. We wanted to use some stemming. There's an algorithm from Porter from like 1980 that's written in SAS code, so we borrowed that to do our stemming so that we could sort of get our verb tenses normalized. And then the core of it was all basically regular expressions. So looking for patterns. So this particular one is looking for some form of broken, cracked, chipped, basically looking for broken. And within 20 characters, 20 of ankle, foot, arm, so we're looking for a broken bone. And then we would flip-flop it in case broken, or in case the body part appeared before break. So we would record both ways. And then if it existed, then we would set a binary indicator indicating that this was a broken bone of some sort. So, anybody here, who uses SAS? Anybody here use SAS? I know you do. Yeah, SAS? Yeah, you use SAS as well.
How did you do the discovery for the core phrases?
I'm sorry, which?
From craft.
Oh, yes, that's well. So partially, that's a good question. Thank you. So partially, it was sort of from we knew what we were going to take the ICD-9s and we were going to sort of classify them into various types of phrases. Generally speaking, because we were looking for auto injury fraud. Generally speaking, if you have some type of broken bone, it's probably not fraud. So that subject matter expertise sort of came into play. In addition to, so we took the ICD-9s and we said, okay, well, what do we want to really look for? And it came down to just a few different things we might want to look for. Things like soft tissue injuries probably tend to be a little more fraudulent, right? So they're a little more subjective injuries. So a lot of subject matter expertise came into play with determining which injuries we would look for. Any other questions? Yes.
Handle the negation problem is no broken and no broken.
This did not. And the reason that's a great question as well. Negation comes up quite often. We were dealing with a character string that was 255 characters long. They didn't have an opportunity to put in much information. So it would be, I won't say it didn't happen, but the fact they probably would not write no broken bones. It would much more likely be the affirmative of what actually happened. So we did not handle negation in this particular case, but it is usually a consideration. And I won't say that we were 100% accurate, but generally because of the length of that string, we just... Any other questions? So the second, this is very, very different. And this was interesting and this was hard. Twitter and sentiment analysis is very, very popular everywhere. I mean, everybody wants to talk about it. Everybody sort of wants to do it, and there's companies out there that do it. So we said, well, let's see if we can do this. Let's see if we can do sentiment analysis on Twitter data. We didn't really have a product in mind. We just really wanted to see, number one, if we can do it. And number two, we were thinking that, well, if we're successful, maybe it'll get people thinking about what else. So let's just do this as an R&D project and see what we can come up with. So our input was just the publicly available Twitter stream using the Twitter API. We were looking specifically for references to insurance companies. So we had a list of the top, say, 20 insurance companies. And we were looking for tweets that were related to them. So Allstate, Geico, State Farm, those types of things. And our output was a number of sort of affinity measures or affinity scores for various insurance carriers. As I mentioned, this was pure R&D. There's no real production considerations. Also, since we did this with Python, so we also sort of explored the MapReduce technology, and I'll explain a little bit about that in the coming slides. That was mostly for curiosity's sake, but it was really interesting. So we chose Python for this particular project, primarily because it has the ability to access the Twitter API. It has a pretty easy interface. It's not too hard to code. It can read and parse JSON files, which is the format of a Twitter file is this .json. So it has a nice library for handling this input, which is one of the key reasons why we chose Python. And it has extensive use of lists and dictionaries, which makes the actual process easy. And it's well suited for MapReduce. And the code to actually do a sentiment score can actually be found online. And this is it. I mean, our code was a little more extensive than this, but that's the basic code to do a sentiment score. And you can find it at this Stack Overflow. So that was another motivation for choosing Python. We didn't have to basically craft the scoring code out of whole cloth. Someone had already helped us out with that. Why did I say this was hard? If regular text is messy, Twitter is a disaster. I mean, it's amazing. Twitter, from a text perspective, Twitter is just a total disaster in terms of the number of things that are in there that are completely meaningless. The amount of garbage information that you have to try to sort out to get to what you're actually trying to measure is just unbelievable. And then, obviously, acronyms, misspellings, shortened words, just really, really, really hard project to get good results out of. So, this worked. We did get output, but this was an interesting project, and it's really hard to do well. So, has anybody used MapReduce? Is anybody familiar with MapReduce? So,
A question on the last one.
Yes.
So, in terms of the variability of the text, what were you using in addition to the sort of standard thing you get out? Were you trying to create dictionaries of different kinds of terminology, or what was sort of behind the text?
What was sort of behind?
Yeah. So for example, people use acronyms and standard Twitter type of acronyms.
Yeah.
Like a dictionary of those? Or?
No, we did not, which is where we had to start figuring that out. No, we did not have a dictionary of those. And so as we started looking at it, so what we would do is we had this affinity score file, which is pretty big. It's not comprehensive. And we would create an affinity score for each tweet. And then we would look at the ones that to get basically nothing out of this. And a lot of it we were finding was just either not legible, and we really couldn't maybe figure out what they were saying, and so we just sort of started then, that's how we sort of was like, wow, this is sort of a mess. We started to sort of do some synonym substitution, but because this was pure R&D, we didn't really get too far with it. We did not have a nice list of, that would be a really great project though, to actually be able to make that dictionary of Twitter terminology. I imagine it would change quite frequently.
It already exists.
It already exists?
Yep.
Can you sell it?
No.
Oh, okay.
No.
So, imagine you're Twitter, and you've got data across thousands and thousands of servers, tweets all across these thousands of servers, and you want to run a process like this. Well, you can't bring that data to your laptop to do the analysis. You basically have to push the analytic to the server to start this thing. So MapReduce is exactly what it says. There's a mapping phase, there's a reduction phase. The first thing that you're usually basically doing is you're creating this partitioned input. For us, this basically meant getting the text from the tweet. The tweet has got all of these fields in it. A number of fields about who did it, who their followers are, where they were at, all kinds of information about the actual tweet. It's a fairly extensive file. All we really wanted was the text. So we created this, we got our text. Then the map function is usually done relatively close to the data, if not on the exact same server where the data resides. This is taking the data and mapping it to something. Usually it's what they call a key value pair. And so we would take this text and we would map it to an insurance carrier. We would say, okay, who is mentioned in this? Is it State Farm? Is it Geico? Is it Progressive? Who is mentioned within this tweet? And we're going to assign it to that bucket. And then the value is the affinity score. So are they saying something positive about this insurance company or negative? So the output of this map phase, we still have one record for every tweet, but we no longer have this massive string of data. We have two data points, the insurance carrier and the value for the tweet, the affinity score. So we have now mapped this into a much smaller set of data. And if you're doing this for real, now you've got across all these servers, you've got Geico over here, you've got Geico over here, you have Geico over here, you have them spread all throughout your organization. In order to do your statistics, you need to bring them all together into one sort of location. This is what they call sort of the shuffle phase. So you bring all these together so that they're all sort of co-located so that you can run them basically all the tweets from a specific carrier can be run on a single server. And then you do the reduce phase. This is basically taking all of these records and compressing it down. So I come up with statistics for each insurance carrier. That basically is number of positive tweets, number of negative tweets, percentage of each, maybe some average score, or whatever metrics. And so when you come out on the back end with this thing, that's why it's called reduce, because you're taking all this data and you're squishing it down into your statistics. So what you come out with on the back end is if we were looking at 20 top carriers, you basically have 20. We map them to a key value pair, and then we reduce them down to basically our output. So we didn't have to do it this way because we're not Twitter, but the two-stage sort of process really fit with what we were doing. So it worked out really well, and it gave us a really good education into sort of what's going on with this technology.
Was this your first usage of MapReduce?
Yes.
So
Yes.
what was that like? You slowed it down to same 64-bit machine.
It was fine. Actually, the whole idea, after you get to understand sort of what's happening in the map phase and the reduce phase, it makes complete sense because you're taking all this data and you're making it manageable. And in this stage, you're basically creating summary statistics. So you use SAS, proc summary. I mean, that's basically what's happening here. They just don't term it that way. So it made total sense. It's not too hard to program. It really wasn't too hateful. There's a website out there called jsmapreduce.com that allows you to actually sort of play with MapReduce. So they have the infrastructure behind the scenes, and all you would do, it's going to take a while to get back to it.
But you have actually loaded it on your machine.
Yeah, we actually loaded it on. We actually did it on our machine.
Right.
So this JS MapReduce has all the infrastructure behind the scenes. You would basically give it sort of this, and then it would basically handle the mapping and the reduction part of the process. But you would basically write this part of it.